Good day! We are Group 4. My name is Ayuban and my group mates are Jascha Lucot and Harvey Ang. And here are our answers for the problem set.
Number 1. Suppose you pour a gallon of water on a yawning cat 10 feet below your bedroom window. Record the potential energy the water loses, the velocity of water before impact, and true or false if kinetic energy of water before impact is equal to the kinetic energy of the cat after impact. Given are the mass of water, which is 1 gallon or 8.34 pounds, and the height of bedroom, which is 10 feet. Solution for A. Potential energy formula is equals to mzg over gc. Next, we'll plug in our values, then we'll get the answer of negative 83.4 pound-feet. Next, for B, as a body falls freely, it gains kinetic energy from the potential energy loss so that its capacity for doing work remains unchanged. Therefore, delta Ek is equals to negative delta Ep to satisfy the statement. 1 half mv squared is equals to negative mgh. Then we'll get the formula for velocity, which is square root of negative 2gh, and the answer will give 25.32 feet per second. Letter C, the answer is false, since large portion of kinetic energy is converted to other forms of energy, such as sound and thermal energy. Number 2, an automobile having a mass of 2,250 kilograms is traveling at 105 kilometers per hour. What is the kinetic energy in kilojoules and how much work must be done to bring it to a stop? Given are the mass of the car, which is 2,250 kilograms, and the velocity 105 kilometers per hour. Required are the kinetic energy in kilojoules and the work required to stop. Solution for A, kinetic energy is equals to 1 half mv squared. Then next, we'll plug in our values, but we need to convert the 105 kilometers per hour into meters per second. Then we'll get the value of 957,250 joules, or 957.25 kilojoules. Then next, for letter B, from the work energy theorem, it states that the work done with the sum of all forces acting on an object is equal to the kinetic energy of the object. Therefore, the work done required to stop the automobile is 957.25 kilojoules.
Hi there, this is problem number 3. Liquid vapor saturation pressure is often shown on these forms. What is asked is to show how the parameters in the two equations are related. So we start with this form. We know by logarithmic change of this that log base 10 of x is equal to ln x over ln 10. We let x as the saturation pressure in torr. So this becomes ln p sat in torr over ln 10 is equal to A minus B temperature in degrees Celsius plus C. Now we multiply both sides by ln 10. Then we get ln p sat in torr equals A ln 10 minus B ln 10 over temperature in degrees Celsius plus C. So from our original equation, we can convert P sat in torr into P sat in kilopascal. We know that for 1 atm, there is 760 torr. And for 1 atm, there is 101.325 kilopascal, which gives us 101.325 over 760 kilopascal for 1 torr. Now, we substitute this value into our original formula, which becomes ln p sat in kilopascal over 101.325 over 325 for 760 kilopascal is equal to this form. Now, we use the quotient rule, the logarithmic properties, to transform this one into this form, which becomes ln p sat in kilopascal minus ln 101.325 over 760 kilopascal is equal to the same form. So now we convert the temperature in degrees Celsius to temperature in Kelvin by using this formula. So our equation now becomes ln p sat in kilopascal minus ln 101.325 over 760 kilopascal is equal to A ln 10 minus B ln 10 over T in K minus 273.15 plus C. So from this form, we just transpose this value to the other side to get this whole equation. Now we relate this equation to this equation by saying that the value of A is just equal to this whole value, and the value of B is just equal to this value, and the value of C is just equal to this value. Now to simplify the answer, we get A is this value, B is this value, and C is this value. That's all, and thank you.
For problem number 4, we are given with an open-end manometer in which one end is open to the atmosphere. So here are the given, the required, and the diagram. So for part A, since we are given with a gauge pressure, it is okay to neglect the atmospheric pressure. To begin with, we start with the equation PA equals PB. And since PA is equivalent to the 7.5 psi plus Y, or the height of mercury above the bottom of the manometer, and PB is 900 mm mercury, we have 7.5 psig plus Y equals 900 mmHg. Converting 7.5 psig to mmHg, we get 387.86 mmHg plus Y equals 900 mmHg. Transposing Y to the other side to get the height, we have 900 mm mercury minus 387.86 mm mercury, we get 512.14 mm mercury as the height of mercury above the bottom of the manometer. For part B, we got a new height for the mercury level in the visible arm, which is 900 mm mercury minus 512.14 mm mercury, we get 387.86 mmHg. And since in the problem it stated that on the visible arm it drops by 25 mm mercury, meaning on the other side it raises to 25 millimeters. So we have 387.86 mmHg minus 25 mmHg times 2, we get 337.86 mmHg. Converting to PSI, we have 6.53 PSIg.